Hey, folks, it's Monday, November 7th. I hope you had a great weekend. We're going to continue with the geometric mean idea. We'll get through this. This is one of the most difficult topics that we're going to see all year long. I thought you did a great job on Thursday in small groups and then presenting it to class, and people sat back and watched. And then on Friday, you watched me present a little bit of information. And some people tried it, and other people said, you know what, I'm just going to work on Alex today. That's okay. Today, I'm going to expect everybody to give their best shot, and I'm going to help you out if it's still a little confusing. I hope I can help you. So, first of all, what the heck is a geometric mean? Instead of adding the two numbers and dividing by two, that's called the arithmetic mean. The geometric mean is multiplying the two numbers together and taking the square root. So, square root of 16 times 23. It happens to be the altitude dropped to the hypotenuse. So let's draw a little right angle right here. So if you had a right triangle, and the right triangle is sitting kind of in a funny way, here's the hypotenuse right down here. The altitude dropped to the hypotenuse is the geometric mean of the two segments that the altitude cuts the hypotenuse into. So when the altitude was dropped down here, when the height was dropped to the hypotenuse, it cut the hypotenuse into two pieces. We use the number 16 and 23 just based on a story I was giving you on Thursday and Friday. So if you were gone both those days, you're like, where'd 16 and 23 come from? It's just numbers that I made up. I mean, this one looks a little bit smaller than this side over here. So I said this one could be like 16 inches long, then this one would be 23 inches long. Well, not then it would be, but I just made those numbers up. Anyways, if you notice, X is like right here and 16 is right here on this triangle. Now things get a little bit more complicated. Let me grab this triangle right here. Oh boy, let me undo whatever I just did. Let me see if I can grab this. No, I think I got to choose this guy. I'm going to grab this triangle. I'm going to move it right up to where it was a second ago. Do you see how X and 16 are just like in obvious locations? I'm just pulling X right down here and I'm pulling 16 right down here. This next triangle is a little bit more tricky. Let me just try to move it up here first of all. You can see that I've done some kind of rotation to this thing. So I'm going to put it like right in here, and then I'm going to try to rotate it back to where I was before, okay? So here's where the triangle started, like right in there. So I need you to really focus. This is almost like one of those games when you go to the Mariners game and they put it up on the big board, and they move the ball around underneath the hat. I don't know if you remember if you've ever been to a Mariners game, but I'm going to move this triangle and you got to pay attention. Where does this X go? Okay. So first thing I'm going to do is I'm going to rotate. Now see the X is moving along this side right here, right? So when I stand it up like this, I know I went a little fast there, but X is down at the bottom side. So this is where the X is right now. Let me put an X down here. And then you notice 23 was rotating over to here. And so what we said is, if these triangles are similar to each other, which they are, they're similar to each other. Look, let me move this triangle here again one more time. I'm going to move this triangle and I'm going to put it so that the angle, I'm not worried about it fitting perfectly on top of this triangle down here, but you notice this angle right here is identical to this angle. See how it's just lining perfectly up? It fits like right in there, right? And then if I was to do the same thing with this triangle, I would have to do a little, I mean, obviously this triangle just came from here, but if I wanted to check to see if this angle fit in there, I'd rotate it over and then I would see if it fits like right in there. So you can see that they share a couple angles, right? That's all it takes for two figures to be similar to each other. Like, this angle is the same as this angle, and they're both right triangles. So we know the two triangles are similar, and now I have them sitting in the same type of orientation. Okay. Now, later on in the homework, we're going to actually have to match up some letters. So let's say I put some letters on here, like this is A, this is B, this is C over here. So I've got A right up here, right? And I got B right over here because this guy just pulled straight down. It didn't do any rotating. Then I guess I need a point for this one, D. I'm going to call this one D right here, right? Well, D is this right angle that's sitting right there. So that hasn't moved at all. But you remember what I did is I rotated this triangle right here, didn't I? Didn't I rotate that triangle? So let's take another look one more time. Okay. So I'm going to rotate this triangle back to here, and then I'm going to put it right back to where it was before. So you notice this point right up here is A. That vertex is A. And obviously the right angle is D, so that's not messing with anybody, I hope. And this one is C. Let me rotate that guy back to it's kind of like so all the corresponding sides are in similar locations, right? So what the heck just happened? Well, this point right here was A. Remember how that was right up there? Obviously this is D. And then this was C. It was sitting right in there. So it's really close to where it was before, right? All right. Well, if I was going to make a similarity statement, I'd go A, B, D. So triangle A, B, D is similar to triangle. We did not do this the other day. So A right up here corresponds with C in this triangle, and B right here corresponds with A right down in this triangle. So I'm going to go C, A, D. I know it's weird that the letters are in different places. Like, why is A not in the same place as this A over here? That's because, like, let's look at A up here. A is just a sliver of what A was in the big triangle, and A up here is the other side. So it's like this is angle 1 and this is angle 2, right? See, this is angle 1 and this is where angle 2 is right down here. Angle 1 and 2 aren't equal. This is not bisecting the angle, right? So we're going to be asked to do this in one of our homework problems, is try to match up the corresponding angles. Very challenging to do. Very challenging to do. Let's try one more, okay? So I'm going to take this triangle right here, and I got to choose the correct tool. I'm going to take this triangle. I'm going to copy and paste it so it doesn't go any, so I have an extra copy of it. And then I'm going to pull that triangle right down to here. And then I'm going to rotate it. Okay. So if I rotate it and I stand it up, it's obviously not in the same orientation these two are in, right? I mean, we got the right angle on the left. These right angles are on the kind of the right side of the triangle. So I could flip it. Okay. So this guy right here flips it. So I flip it left and right. And now I want to test to see if this angle right down here matches into B right over there. So let's see if I drag this guy right over to here. Is it matching up? It sure is. Look at that. Perfectly matching up, right? So I know that this angle right here, I'm going to put 2 tick marks on it. This angle is right there. That one has 2 tick marks. This has the right angle. Now look, the right angle in the big triangle was A. So I'm definitely going to put an A right up there. The single ticked angle, where the heck is the single ticked angle? Well, this single ticked angle was C right here. See it? So that's got to be C because that has the single tick on it. And then the double tick has B over here, right? So B is where the double tick is. So I'm going to put a B right in there. Okay. So this one right here would set up as, see, I was going single tick, double tick, right angle. So it's going to go CBA for the big triangle. CBA. Sorry that's a really bad similarity squiggle. All right, boy, that's going to be a challenge, isn't it? Why is this important? Well, we prove that X is the geometric mean of 16 and 23 by going like this. We said 16 over X. We said 16 over X is equal to X over 23. We're just matching up corresponding sides. See, once we have them oriented in the same positions or same relative side lengths, then we can set up a proportion. We get X squared equals 16 times 23. And then to get rid of the squared on the X, if I'm trying to solve for X, I take the square root of both sides and I get 16 times 23. See, this means that X is the geometric mean of 16 and 23, which I know I said up here, but I never gave you a proof of why that works. I mean, well, we did it on Friday. So you may have fast forwarded through a little proof just now because you watched it on Friday and you were like, hey, I totally understood it on Friday. However, this idea of matching up the 3 triangles and making a similarity statement, that might be kind of new to you. All right. Now, which other sides were geometric means? This side right here was the geometric mean, and so is this side right over here. So let's make sure we have those in our notes like we had X in our notes, right? X was this side right here, the altitude. Y is a leg in the big right triangle, and Z is also a leg. And I didn't do a proof of that. We could do a proof, and I might do that at the end of my video right now. I know I'm going to make this video kind of long. So we said Y was the square root of 16 times 16 plus 23. So I'm just going to put down 16 times 39, right? Because the whole side length is 39 long, okay? And Z is the geometric mean of 23 and 39. Okay, so make sure that you have these in your notes, and I hope that we can use these notes even if the triangle is oriented in a different way. We can try to figure out, where the 16 side is and where the 23 side is. So we're going to try that right now. I'm going to try it on problem number 1 down here from part 1. And if you already finished this problem, you figured it out on Friday with your partner, you can skip through the video, of course. So look, 3 is where the x was right up above, right? So I could try 3 is the geometric mean of 2 and x, but that doesn't get me anywhere because I don't know what. Oh, wait, it does, doesn't it? 3, oh, geez. Let me try that again. 3 is the geometric mean of 2 times x. Now, you might say, well, what's x doing down here? I thought x was on this side. Well, not every time. I mean, they can give us different given information, but we have to identify, here's our big right triangle, and then here's the altitude drop to the hypotenuse of the big right triangle. So the altitude is the geometric mean of the piece on the left times the piece on the right. And so here we go. Now I square both sides. I get 9 equals 2x. Then I divide by 2. Now you might say, where'd that 9 come from? I squared this side. So I also have to square this side to get rid of the square root. The square root and the squared are inverses of each other. So the squared undoes the square root. We're just left with 2 times x. Now we divide both sides by 2, and I end up with x equals 4.5. So this piece right here is 4.5. Then what I can do is I could say, well, z is 6.5 because we're just going to add the 2 and the 4.5 together, right? Then I could look up above and I could say, oh, wait, you know what? We said right up here that y is the geometric mean of 16 times 39. And I've got, well, the y is in the same exact spot that our y was in our notes. So we could say y is the geometric mean. So that means y equals the square root of 2 times 6.5. 2 times 6.5. All right. So you're going to do this one obviously on Desmos or, wherever you got your calculator on your cell phone. And then you'll round it to the nearest tenth, I think they want you to do. Okay. Hey, what if you get one like this? Find the geometric mean between 4 and 6. Find the geometric mean between 4 and 6. Well, that's just saying, hey, x is the square root of 4 times 6. You multiply 4 times 6 together, and you take the square root of it, and so we get the square root of 24, okay? Now, they might ask you to round to the nearest tenth, or they might ask you to simplify this. When they say simplify this, what they're saying is 24 is the same thing as 4 times 6. Now, why did I break it apart as 4 times 6? Because 4 is a perfect square, and I could write it as the square root of 4 times the square root of 6. That is the square root of 24. I could write it this way. And the square root of 4 is 2. So I write 2 square root of 6. Oh, doggone it. 2 square root of 6, because that 6 has to stay underneath the square root sign. And so this is called simplified radical form, or I've just simplified the square root of 24, but it's still an exact value. It's not an approximation. This is going to be really close to 5, right? Because the square root of 25 is 5. So, if you stick it in your calculator, probably going to get about 4.9 maybe. All right, number 7. It says, here's the one I'm really kind of worried about, right? So let me zoom in on this guy. It says, select the similarity statement identifying the 3 similar triangles. Well, what might help us is that we put some numbers in here. Like in our notes on Friday, I said, let's pretend like that's 60 degrees. If this is 60 degrees, this is a 30-degree angle over here because you've got 180 to use up for all 3 angles. And you got 90 right up here. So 90 and 60 make 150. You got 30 left there, right? Same here. If you went 60 here, that's 90. That means this is 30 here. That means this is 60 right over here. So if it goes SRU, triangle SRU, that would be similar to, well, I just went 30, 60, 90. So I got to go 30, 60, 90. So that'd be TRS. That's for the biggest one, the biggest triangle, TRS. And then it's similar to triangle. I went 30, 60, 90 on the first one. So I got to go 30, 60, 90 on the other ones, TSU. So I go TSU. Remember that tricky question I asked you guys on Friday? How many triangles do you see here? And some people thought they saw 2. Other people said 3 because there's a triangle on the left, there's a triangle on the right, and then there's the big whopper triangle, right? And so in my statements here, I got triangle on the left, I got big whopper triangle, and then I got the triangle on the right over there. Hey, does that mean their answer choices have, SRU lined up like this? Maybe not. Maybe they mess with us and they put USR. So if we went USR, then this one has to be STR because I went third, first, second. So you got to switch this around and go third, first, second. You have to do the same over here. You'd have to say third, first, second. If they switch the letters around, hopefully you can manage that. Whoo, man, thanks for watching my video, everybody. You're doing fantastic. Keep taking good notes, following my video, trying the homework problems, ask me questions as I walk around. Don't give up. You can do it.